Welcome to the 8th grade Math Homework Helper Series. Tonight's homework is SE5, solving systems of equations by combination using elimination or addition. Let's quickly go over the steps you're going to need to follow to be able to do these. For making a variable disappear when combining the equations together, you're going to need to line up the like terms and the equal signs for each equation. Choose one of the variables and then make sure that the signs for that variable in each of the equations are the opposite or inverse. Add equations together, forcing a variable to be eliminated. Then you want to solve the new equation. Substitute the answer from the new equation back into the old equation. Solve for the second unknown variable, which is going to get you a solution. And then you want to write that solution as an ordered pair and then put it back into the two equations and check it. Okay, let's put that into play by taking a look at question number 4. Number 4 gives you two equations, 5x minus 2y equals 20 and 2x plus 3y equals 27. Now if I look at my two variables, I have a 5x and a 2x, both of them positive. I have a 3y and a 2y. The 2y is negative and the 3y is positive. Now I need to have opposite signs for whichever of these two I choose. Since I already have opposite signs for my y's, that seems like the best way to go. Now I just need to get the numbers to be the same, and that's where I'm going to jump into step 1. So I choose to multiply the 3 by a 2 and the 2 by a 3. And so that'll get me 6y for each of these equations. But in order to do that, I've got to multiply, in this case, the 3 by everything up here. And when I come down here, I've got to multiply the 2 by everything inside here. So on the top, I'm going to get 15x minus 6y equals 60. On the bottom, I'm going to get 4x plus 6y equals 54. Now my goal in this was simply to get these to be the same number. They already had the opposite signs, and because I have that now, I can move on to step number 2. For step number 2, I want to take the two new equations and I want to subtract them from each other. So in this case, or add them together, depending on how you want to look at it. So in this case, the 6's cancel out. 15x plus 4x equals 19x, and 60 plus 54 equals 114. Now I divide by 19, cancels that out. Divide by 19, I get 6. So now I know that x equals 6, and knowing that, I'm going to try to solve for y. So taking a look at step number 3 now, knowing that x equals 6, I'm going to plug that back into the 5x minus 2y equals 20. So that's going to be 5 times 6 minus 2y equals 20. So 30 minus 2y equals 20. And if I subtract 30 on this side and 30 on this side, I'm left with 2y equals negative 2y equals negative 10. If I divide by negative 2 on each side, I'm left with y equals 5. So now I can go to step 4 with a solution. That solution is going to be 6, 5. So let's pull step 4 down here. And with that solution, I'm going to do a check for each equation. So I have 5x minus 2y equals 20. Well, for the x, I'm going to substitute 6. For the y, I'll substitute 5. Then I'm going to go ahead and solve the problem out. 5 times 6 equals 30. Minus 2 times 5 equals 10. So 30 minus 10 equals 20, which gives me 20 equals 20. There's a check. It worked for this equation. Let's try it for the other equation. Substitute the 6 for the x, the 5 for the y. 2 times 6 is 12. 3 times 5 is 15, equals 27. 12 plus 15 equals 27, so 27 equals 27. That is also a check. And that tells me that my system is consistent. Okay, let's take a look at another problem. A problem that looks similar but is actually in reality very different. So we have 2m plus 3n equals 8. We have 4m minus 16 equals negative 6n. Well, the first thing that jumps out at me is the order of this, the way it's set up. In order to be able to compare these two and get them so that my m or my n is the same but inverse of signs, I need to get this n over to here and this 16 over to here. So my first step is going to be in rearranging this equation. So I'm going to have to add 6n to both sides and add 16 to both sides. Let's take a look at how we do that. So taking that 4m minus 16 equals negative 6n, I'm adding 16 to both sides, which cancels it out over here and brings it over to this side, which gives me 4m equals negative 6n plus 16. Then I need to add 6n to this side, which cancels it out, add 6n to this side, which gives me 4m plus 6n equals 16. So now it's in the same format as the 2m plus the 3n equals 8. I didn't have to do this before. It was already set up. But if it's not set up, this is the steps you're going to have to take to get it that way. So now that I have this set up, I can now jump to step number 2. I have 2m plus 3n equals 8 and 4m plus 6n equals 16. Well, I'm looking at the ends, and I can see that I can get 3, if I multiply it times negative 2, to a negative 6. I also recognize that when I multiply negative 2 times the 4, it's going to give me negative 4. So both of these are going to have an equal but opposite signed partner. So let's see how that actually works out. So multiplying through by negative 2, I have negative 4m minus 6n equals negative 16. And now I have to go to step 3, which will be subtracting those. So if I subtract, and each one is the inverse of the other, I wind up with 0 equals 0, which kind of stops me in my tracks. I can't do a check. I can't solve. I can get no solution, because anything that I plugged in here for m or n is still going to wind up with 0. So what that means, and this is something we haven't seen yet, is that all values that work in one equation will work in another. That means the system that we're looking at is a dependent system. Please use the questions that were done for you tonight to help you to answer the additional problems that are in your homework. And remember, the key to success in math is not only working hard, but working smart.